Welcome! In this tutorial, we're going to take a deep, hands-on look at Ideogram 4, Ideogram's first open-weight text-to-image model. We'll run everything locally on a single RTX 4090. I'll walk you through what the model is, the quantization formats it ships in, its 3 quality modes, and its most distinctive feature, structured JSON prompting. Then we'll review a full gallery of images I generated across many styles, and finish with real performance benchmarks from my own machine. So what exactly is Ideogram 4? It's the first model that Ideogram has released with open weights, and importantly, it is not a fine-tune of anything else. It's a 9.3 billion parameter foundation model, trained entirely from scratch. Its specialty is design, rendering text inside images, controlling layout, and following color direction. On third-party leaderboards, it's the top-ranked open-weight image model. On Design Arena, it trails only the giant proprietary models from OpenAI and Google, and it leads every other open model by a wide margin. Under the hood, Ideogram 4 is a fully single-stream diffusion transformer. That means text tokens and image latent tokens are concatenated into one sequence and processed together through the same 34 transformer layers. There are no separate text and image branches, so the two modalities interact deeply at every layer. The text encoder is also unusual. Instead of CLIP or T5, it uses Qwen3VL, a full 8 billion parameter vision language model. Hidden states are pulled from 13 different layers and concatenated, giving the image model both surface-level token detail and deep semantic understanding at the same time. 4 capabilities make this model stand out. First, text rendering, mastheads, headlines, signage. It's the best of any open-weight model, ahead of much larger models like FluxToy2Dev at 32 billion parameters. Second, you can place elements explicitly using bounding box coordinates in the prompt, which is something even most closed models can't do. Third, you can pass exact hex colors, and the model will follow that palette. And fourth, it natively generates anything from 256 to 2048 pixels, in aspect ratios as extreme as 6:1. The magazine cover you're looking at was generated in one shot, typography and all. Generation works through flow matching. Rather than predicting noise like classic diffusion models, the network predicts a velocity field, and we integrate an ordinary differential equation from pure Gaussian noise back to a clean image using simple Euler steps. Classifier-free guidance is dual branch. There are actually 2 separate transformers, a conditional one that sees your text and an unconditional one that doesn't. The clever part is that the negative pass is asymmetric. It only processes image tokens, with no text padding at all, which makes it noticeably cheaper than a full second forward pass. Let's talk about how the model actually ships. The weights are published on Hugging Face in 2 quantization formats, and choosing the right one matters. It decides what hardware you can run on and how much memory you'll need. At 9.3 billion parameters, the full model in 16 would need far more memory than a consumer GPU has, so quantization is what makes local inference practical at all. First format is NF4, normal float 4-bit, loaded through bits and bytes. Each transformer branch compresses to around 5 gigabytes, and the whole pipeline, both DITI branches, the text encoder, and the VAE, sits at roughly 16 gigabytes resident. That's a perfect fit for a 24 gigabyte card like my RTX 4090, with headroom left for activations. The catch, it's QDA only. The second format is FP8, using the E4M3 encoding. It's weight-only quantization, activations stay in float 16, so it doesn't need FP8 hardware and runs anywhere, including Apple Silicon and CPU. If you have an NVIDIA card, take NF4. Otherwise, FP8 is your friend. Next, quality modes. Ideogram 4 ships with 3 named sampler presets: Turbo, Default, and Quality. They all use the same model and the same guidance recipe. What changes is simply how many integration steps the sampler takes. I tested all three extensively on my 4090, and the trade-off is exactly what you'd hope: speed against fine detail and typography fidelity. Here are the three modes side by side. Turbo runs just 12 steps. At 1024 square it finishes in about 21 seconds on my card, which is great for exploring ideas. Default runs 20 steps in about 32 seconds, and is the preset I use for day-to-day work. Quality runs 48 steps, taking about 72 seconds, and it's what you want for final renders and anything with small text. All three share one interesting trick. Most steps run at a guidance weight of 7 for strong prompt adherence, but the final few steps drop to guidance 3, gentle Polish passes that clean up artifacts right before the image resolves. This is the entire preset registry from the source code. It's refreshingly small. Each preset bundles a step count, a per-step guidance schedule, and 2 noise schedule parameters, mu and sigma. There's one genuine gotcha worth remembering if you ever write your own preset. The guidance schedule is stored in loop index order, which means index 0 is the final polish step, not the first step. You can see the pattern clearly. Quality is 45 steps at guidance 7 followed by 3 polish steps at 3. Turbo squeezes that into 11 plus 1. Adding your own preset is just adding a dictionary entry. Now we get to the feature that makes Ideogram 4 genuinely different from every other image model I've used: structured JSON prompting. The model wasn't trained on casual text captions. It was trained on rich, structured JSON descriptions of images. You can still type a plain sentence and it works, but when you speak the model's native language, JSON, you unlock a completely different level of control. The schema has 3 top-level parts. High-level description is a single sentence summarizing the image. Style description carries the aesthetics, lighting, medium, an optional list of exact hex colors, and exclusively one of a photo field for photographic work or an art style field for everything else. The real power lives in compositional deconstruction, a background description plus a list of elements, where each element is either an object or a text item, with its own description and an optional bounding box in a 0 to 1000 coordinate space. The microservices diagram on this slide is the proof. Every service box landed exactly where its bounding box said it should. Here's a real caption, trimmed from the exact JSON that generated the AWS diagram you'll see in the gallery. Notice how concrete everything is. The palette pins AWS signature orange with literal hex codes. Every element declares its type, object or text. Text elements carry the exact string to render, so the model isn't guessing at spelling. And the bounding boxes use imin, xmin, imax, xmax in that 0 to 1000 space, independent of the output resolution. When I generated this, every single service icon appeared inside its declared box. This is layout control you simply cannot get from a sentence. Writing those captions by hand is powerful but slow, so the repo ships with Magic Prompt, a large language model that expands your one-line idea into a complete schema-compliant caption automatically. There are several backends. Ideogram's own hosted endpoint is completely free. You just need an API key from their developer site. There are Cloud Opus and Cloud Sonnet configurations that run through OpenRouter using an open-source system prompt that ships in the repository. And I added my own backend for Gemini Flash Lite, which costs a fraction of a cent per expansion. The expansion is aspect ratio aware too, so composition advice matches your target canvas. Let me show you what this looks like in practice. I typed 11 words. A ginger cat wearing a tiny wizard hat reading a spell book. The Magic Prompt expanded that into roughly 3,000 characters of structured caption. And look at what it invented. A twilight study. A candle on the left and a glowing sigil on the right, with the cat's face deliberately lit warm amber on one side and cool cyan on the other. A crystal ball with violet mist. It even added a text element, a hand-lettered chapter heading on the book's page. Every one of those details showed up in the final image. That's the value. The LLM does the art direction, and the image model executes it faithfully. Time for the fun part. I built a library of 14 handcrafted JSON captions covering wildly different styles: photorealism, classic painting, cartoons, doodles, vector art, storybook illustration, software diagrams, cloud architecture, infographics, and magazine covers, in both English and Arabic. Everything you're about to see was generated locally on the 4090 at 20 steps with a fixed seed. For each group, I'll show the image and give you my honest quality assessment, including where the model stumbles. We start with photorealism, a studio portrait of an elderly fisherman from a handwritten JSON caption. I asked for a single Rembrandt key light from the upper left, an 85mm portrait look at f2, a navy cap, and a cream wool sweater. The model nailed every requirement. Look at the skin, the wrinkled detail, the white stubble, the catchlights, and the pale blue eyes. This is poor-level realism with no uncanny artifacts anywhere. My only nitpick is that I asked for the hint of a smile and got a more neutral expression. I scored it 9.5 out of 10. It would pass professional review. Staying photorealistic, but pushing resolution. This snow leopard was generated at a native 2048 squared, no upscaler involved. The workflow here was the full pipeline. I typed one plain sentence. My Gemini backend expanded it to JSON, and the model rendered it. At this resolution, the pipeline peaks at 23.3 of the card's 24 gigabytes. It just barely fits, and I had to add some memory optimizations to make that happen, which we'll touch on in the benchmark section. The golden hour rim lighting on the fur is exactly what the expanded caption specified. Switching the style description from photo to art style transforms the model into a painter. This Renaissance portrait asked for sfumato blending, those hazy Leonardo-style edges, fine glazing layers, and even subtle craquelure, the hairline cracking of old varnish. The emerald velvet gown with gold-embroidered sleeves is exactly as captioned, and the window with its atmospheric blue-green landscape landed precisely in the upper right where the caption placed it. 9.5 out of 10, genuinely museum grade. The lesson: this model has deep art history vocabulary, and the more specific your art style field, the more it rewards you. Into stylized territory. The cartoon fox inventor got at every prop I asked for. The brass goggles pushed up on the forehead, the leather tool belt, the little hovering robot with one friendly eye giving a thumbs up. But here's the most interesting miss of the whole experiment. I asked for flat, cel-shaded TV cartoon styling, and the model drifted toward a richer, painterly storybook look. Charming, but not the register I specified. The companion doodle piece, a coffee-themed notebook page, rendered its bouncy hand lettering perfectly, with the French press and dancing croissant intact, 8.5 and 9 out of 10 respectively. Two more illustration styles. The Desert Dunes piece shows the model handling minimalist flat vector design, smooth layered silhouettes, a restricted warm palette, and the striped hot air balloon floating exactly in the bounding box I declared for it. And this lighthouse scene was the single best prompt adherence result of the entire set. The girl in the yellow raincoat holding her lantern, the terrier in its tiny matching coat, 3 glowing windows down the striped tower, the beam cutting through diagonal pencil stroke rain. Every clause of the caption is in the image. 9 and 9.5. Now the engineering categories, and this is where bounding boxes really earn their keep. This CI/CD pipeline flowchart placed all 5 stage nodes in a perfect horizontal flow, each inside its declared box, with the right icons and the deploy stage correctly highlighted green. 4 of the 5 labels are pixel perfect. Scan came out as SCAH, and one small stray caption of garbled text appeared below the diagram. That's the recurring pattern with text-dense layouts. The big structure is rock solid, but small labels can wobble. 8.5, completely usable after 30 seconds in any image editor. Cloud architecture diagrams were my favorite surprise. This AWS serverless design is the standout. CloudFront, S3, API Gateway Lambda, and DynamoDB each rendered with believable AWS-style iconography, every one inside its bounding box, with the dashed cloud boundary and the user icon outside it, exactly as the caption deconstructed it. The Google Cloud and microservices diagrams kept the same structural fidelity. Nothing was ever misplaced, but picked up small, loadable typos like pubsuck for pubsub and AFI gateway for API gateway. The takeaway: trust it with topology, double-check the small print. The editorial categories. The coffee infographic delivered its headline, both big statistic callouts, 2.25 billion cups, 25 million growers, the 4 ascending bars, and the source line all correctly. But the numbers printed inside the chart garbled, which taught me a rule of thumb: words render better than digits. The Circuit magazine cover is near print ready, and notice the masthead. I asked for the robot's head to partially overlap the letters for depth, and the model executed that layering exactly. The main cover line is perfect. Wall teaser line wobbled. 8.5 and 9. And now the honest part of this review. Arabic. I deliberately saved these for last because the results are a mixed story. Structurally, this water conservation infographic is impressive. The layout flows right to left as Arabic must. Text blocks are right aligned. The 3 tip cards sit in their bounding boxes, and it even used proper Arabic Indic numerals for the list. But read the actual text and the quality drops sharply. The title has inserted phantom letters, and the body copy is heavily garbled with duplicated word fragments. Arabic scripts connected. Contextual letter forms are clearly much harder for the model than Latin text. 6.5 out of 10. Same story on the Arabic magazine cover, with one big positive. The photography is genuinely stunning. The Andalusian horseshoe arch, the carved stucco detail, the golden pre-sunset light, and the gold-on-green palette followed my hex codes exactly. The typography is where it struggles. The masthead should read Ufuk, horizon, in 3 letters, but extra phantom glyphs attach themselves to it, and the main headline starts correctly and then degrades. My practical rule from these experiments: with Arabic, keep text short and display-sized. Large single words fare far better than paragraphs, and expect artifacts that need manual cleanup. 7 out of 10, carried by the photography. Let's close with hard numbers. I benchmarked all 3 quality modes across 7 aspect ratios, 21 runs total, with a warm-up pass excluded and proper QDA synchronization around every measurement. Each timing covers the complete pipeline, text encoding, all the sampling steps, and the VAE decode. These are real wall clock numbers from my machine, not marketing figures. Turbo mode first. At the standard 1024 square, an image takes about 21 seconds, fast enough to iterate on ideas comfortably. A wide 4:1 banner is even quicker at 12 seconds, because what matters is total pixel count. And that's the headline lesson hiding in this chart. Look at the 2048 square bar towering at 2 minutes. Same 12 steps, 6 times the time. Resolution, not step count, is what dominates cost. Each step at that size processes over 16,000 image tokens through quadratic attention. Default mode, 20 steps, is what I used for the entire gallery you just saw. Half a minute for a square image, 51 seconds at 1.5 megapixels, 73 at full HD sizes. One detail in this chart worth appreciating: 16 by 9 landscape and 9 by 16 portrait take identical time. Down to the decimal, orientation is completely free, only the pixel count matters. For the quality you saw in the gallery, half a minute per image on a consumer GPU is a remarkable deal. Quality mode, 48 steps, costs almost exactly what arithmetic predicts. About 2.3 times the default preset at every size, because per step cost is constant. 72 seconds for a square image is perfectly reasonable for a final render. And remember, this is the preset that helps most with small text, so it's the right choice for the typography-heavy work this model excels at. The one number that demands respect is the corner case. Quality at 2048 squared 462 seconds, nearly 8 minutes for a single image. Spectacular results, but plan your coffee break. Putting all 21 runs on one dashboard reveals 3 clean laws. First, time scales linearly with steps. The per-step cost panel shows nearly identical bars across all 3 presets at every size. Second, time scales superlinearly with pixels. 4 times the area costs about 6.3 times the time, sitting between linear and the quadratic reference line on the log-log plot. That's transformer attention at work. Third, peak memory depends only on resolution, never on steps, climbing from 17 to 23.3 gigabytes, kissing the 4090's ceiling. The practical recipe: draft in turbo, work in default at 2 megapixels or less, and save high-resolution quality renders for finals. And that's the tour. We covered what Ideogram 4 is, then F4 and FP8 formats, the 3 quality modes and exactly what they cost, structured JSON prompting with LLM-powered magic prompts. And we looked honestly at 14 generations across every style, including where Arabic typography still falls short. If you want to go deeper, the full written analysis, with every JSON prompt, the complete quality scorecard, and all the benchmark data is on my blog. Scan the QR code on screen, or find the link in the description. Everything in this video was produced locally on a single RTX 4090. I'm Omar Hosni. Thanks for watching, and go generate something beautiful.